Welcome back. This is an Aleks training video on interpreting a graph of molecular speed distribution. This is a speed distribution curve called the Maxwell-Boltzmann curve. We've seen the Boltzmann constant in terms of using this. This is the graph of that constant in terms of how any one particle of gas is going to be moving at different probabilities. So it's a probability problem. What's the probability that the gas will be moving very, very fast or very, very slow, or most of the ones in the middle? Like if you were to say in 10th grade class, how many students would make a perfect 100? How many students would make a 77? You would have most everybody making C's or B's, a few making high grades, a few making lower grades. So you're going to have a curve just like this. So this is a curve. You're going to have only a few people making a very, very small, slow speed here. These are speeds. Only a very few of the molecules are making a very, very fast speed. Most of the molecules are making this speed. This is the average. So it's the bell curve, if you've ever seen a bell curve. Now what I've drawn, let me show you what I've drawn. What I've drawn is the top of the curve. This area is where it's most likely, the most likely speed that you're going to see. Okay, and then so I just put a line here, and then I put a 90-degree line here, and then guessed, just a guesstimate, because there's no way of making a perfect guess here. This is, this is only 250 apart. So I just made a guess. I don't know if I'm right or wrong. And then I wrote it down. Now you could do this, just with your finger. You could just do this looking and guessing, or using a ruler like I did, whatever. So then this is where it's most likely. And then I counted up the blocks and saw that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks high. And the second question, was, what higher speed is only half as likely as the most likely speed? Okay. All right, so the most likely speed is here, because this is where the peak of the distribution curve is. And now the higher speed is up here. Where is it half? Well, this is 10, so where is it 5? So I just counted up to where it was 5, drew a line straight across it at 5, and then brought a line down, and then made a guess. Again, it's a guess. No idea. Okay, it just looks close to me. Okay, it looks just like a little, like this block looked just a little, sorry. This block just looked a tiny bit smaller than this block. And then the last one was 10%. What higher speed was only 10% of the most likely speed? So if the most likely speed was 10, then 10% would only be 1. So I just brought it up, I went across to 1, and then brought it down and made a guess. Okay, and that's it. That's all that you're asked to do. Okay, so looking at it, the first question said, and this is a real stickler. You have to be careful, because you'll miss these really easily, because Aleks is only taking within 125 meters per second as the right answer. So if you're not in that, you're not going to. Okay. So here's my guess. What's the most likely speed of the helium atoms in this sample at negative 36 Celsius? I would say it's 990 meters per second. Okay, total guess, 990 meters per second. All right, what higher speed? Okay, so that means if it's higher speed, I have to go this way, not this way, because of course there's two sides to this hump. I'm going higher speed, so I'm going this way. What higher speed is only half as likely as the most likely speed? So I find the 50, brought it down, and this was 1740 meters per second. Okay, and then what higher speed is only 10% as likely as the most likely speed? I've got here at 2200 meters per second. Okay, now I looked up the answers to this one, and I wasn't right on. I was close, pretty close a couple times. The first one's right answer was 992. Do you see that there's no way to know because I don't have a graph that gives me all these tiny grids. I'm making a guesstimate, but you have to make it close enough to 125. Okay, so this first one was there. What the second one I guessed 1740, and this was 1624. So let's see if I was within. So 1740 minus 1624. It's within 116, and it's 116, and I am within 125. So I barely squeaked that one right. And then the last one was 2200. It was 2194. I was within 6 meters per second. So I'm awesome on that. Okay, so this is not hard. All you're doing is looking at a graph and measuring the marks on a graph. I think you can do it.